Hello. In this video, we are going to deep dive into one of the most powerful and flexible data structures in Go, slices. So let's start with the basics. What is a slice? A slice is a dynamic, flexible view into an underlying array. Unlike arrays, slices have no fixed size. They can grow and shrink as needed, making them incredibly useful and versatile. To create a slice, we usually use the make function. So let's start the IDE and write some examples. Before we write any code, let's create the main function. Now let's create the slice of integer called mySlice. So mySlice. To make the slice, we use the function make. The first argument is the type that we want to make. In this instance is a slice of integer. The next parameter is the length of the slice. In our instance is going to be 0, and the last parameter is going to be the capacity of the slice, which in this instance is going to be 10. In this example, we created a slice named mySlice. It's initially empty because the length is 0 and the capacity is 10. We can also initialize a slice with the values. So let's create a new slice called fruit slice. And let's add some string values to it. So let's add apple, banana, cherry, orange, and pear. Now, fruits slice contains 5 string elements. As you can see, the slice initializations looks very similar to array initialization. The only difference is that when initializing the slice, we do not provide the number of elements inside square brackets. We can create new slices from existing slices or existing arrays using the slice notation. So for example, if we want to create a new slice from the existing slice, fruit slice, containing the first 2 fruits, we would use the following syntax. So new slice would be fruits slice and then 0, 2. Since we are starting from index 0, we can actually omit the 0 and write the statement as follows. So this would be exactly the same. If we wanted to create a slice that would contain the last 3 elements of the slice, fruit slice, we would use the following syntax. So for example, slice 2 would be fruit slice. We starting from index 2 and the rest of the elements. We can also create a slice from an array using the same syntax. So let's declare an array first. So let's call my array and let's make it 5 elements of type int. And let's write some values. And then, more than 5 elements. And then we can create a slice, for example, slice 3, and would be my array. And then we can choose the index, the starting index. So let's start from index 1 and let's go up to index 3. We can find out the length of a slice by using len function and capacity by using cap function. So let's write out the lengths and capacities of the slices that we have defined so far. To do that, we will use the fmt printf command. Len is going to be a number, cap is going to be a number, and we will write out the value also, which in case is the elements of the slice. And let's not forget carriage return. So let's do len my slice, then cap my slice, and then my slice. Do the same for the fruits slice. And new slice. For the slice 2 as well. And lastly, for the slice 3. So if we run this function now, so we go run main.go. Now, as you can see, the first slice, which is my slice, has the length 0, capacity 10, and has no elements, so it's an empty slice. Fruits slice has a length of 5, capacity of 5, and contains apple, banana, cherry, orange, and pear elements. New slice has length of 2, capacity of 5, and contains 2 elements, which are apple and banana. Slice 2 has the length of 3, capacity of 3, and contains cherry, orange, and pear elements. And slice 3, which is a slice of integers, has a length of 2, capacity of 4, and contains elements 2 and 6. To loop through slices, we can use the range keyword, just like with arrays. So let's get rid of these slices first, and then let's just go through this slice. So 4, we don't want the index, we want the value, range fruit slice, and we can do println v. And then if we run this function, see that we looped through the slice and we printed each element. We can copy the elements of a slice to a new slice using the function copy. So if we want to copy the elements of fruit slice to a new slice, we first define the new slice. First, let's delete the statements that we don't need. Then we can create a new slice called my slice and set the length and the capacity to 5. If the length and capacity are the same, we can omit the last argument in the make function. And now we will use the copy function to copy from, first is the destination, so it's my slice. Then we are copying from fruit slice. Copy function returns the number of elements that were copied from source to destination. So let's get the number as well. And now let's print the details of my slice. Let's do the number of elements copied as a number. Length of the slice is going to be number, capacity is going to be number, and the slice itself. So n, length of my slice, cap of my slice, and then the slice itself. So it's going to be my slice. Now if we run this function, so if we go run main.go, you can see that 5 elements were copied and my slice has the length 5 and capacity of 5, which we defined it ourselves, and the elements on the new slice, which in case is my slice, is apple, banana, cherry, orange, and pear, which is exactly the same elements as in the fruit slice. You might wonder, what happens if our new slice is smaller than the original slice? So for example, let's change the length and capacity of my slice, to, let's say, 3. What will happen now? Well, copy function will copy the only number of elements that will fit in the length of the destination slice. So in this case, it will copy the first 3 elements. So let's see when we run this application what we will get. So as we said, 3 elements were copied. The length and capacity of my slice at this instance is 3, and the elements that were copied are apple, banana, and cherry. We saw what happens when the destination slice is smaller than the source slice. In our case, my slice has got the length and capacity of 3, whereas my fruit slice has got the length and capacity of 5. So what happens if the destination slice is bigger than the original slice? So let's try. So let's say my slice is going to be of length 10, and let's do capacity 20. What will happen? Right, again, copy will copy all the elements from the source to destination. So if we run this function now, see, it has copied 5 elements, but the slice is still, the length of the slice is still 10, and capacity is 20. And the elements are apple, banana, cherry, orange, pear, plus we have got 5 empty strings in here to make up the number of elements which is in the length of the slice. We can also increase the capacity of the slice, but to do that we need to use a small trick. And the trick is, we first define a slice that has bigger capacity than the original slice. We copy the elements from the original slice to the new slice, and then we assign the new slice to the original slice. So let's do that. So let's say we want to change the capacity of fruit slice from 5 to 20. All right. So we need to define a new slice. So let's define a new slice. We use the function make as a string. A length is going to be the length of the fruit slice. So let's do length fruit slice. And capacity, let's do 20. And now we need to copy the elements from fruit slice to new slice, and then we need to assign the new slice to fruit slice. And this is how we increase the capacity of the fruit slice. Now we can print out the details of a slice, our usual printf command. So let's do length is defined as an integer, cap as a number rather, and then the slice itself. So let's do a fruit slice. We need to do this length, len of fruit slice, cap of fruit slice, and then the fruit slice also. Let's print this before we make the copy as well. So if we run now the application, you see we have length and capacity of 5. To view this better, let's just put new line on printf in both instances. Run this one more time. As you can see now, fruit slice before being increased, the length was 5, capacity was 5, and it contained 5 elements. Now, after the capacity increase, length is 5, capacity is 20 now, and the elements are the same again. A common operation on the slice is to append data to the end of the slice. Go provides a building function to do just that, and the function is called append. Append function takes the original slice, the elements to append to the original slice, and then returns the slice with appended elements. If the original slice does not have enough capacity for the new elements to be added, the append function will increase the capacity of the slice, almost exactly the same as we done ourselves in the previous example by using the copy function. So let's append some more fruits to our fruit slice. So let's get rid of these statements, and then let's do fruit slice equals append fruit slice, and let's add apricot, grape, lemon, and olives. And now we will, if we run this application, we will see the length and capacity before appending and after appending. So let's run the application and see what's happening. So you see, our original slice had the length of 5 and capacity of 5, and now the new slice has the length of 9 and capacity of 10. So its length is the number of elements. So it's apple, banana, cherry, orange, pear, apricot, grape, lemon, and olives, which is 9, and the capacity is 10. Now that we have covered the basics, let's dig deeper and find out how slices work under the hood. So let's get back to slides. Slices in Go consist of the header and the underlying array. The slice header is a structure that contains the pointer to underlying array, the length of the slice, which is the number of the elements in the slice, and the capacity, which is the maximum number of the elements the slice can hold without relocation. So when we declare a slice, which in our case is my slice, Go will create the slice header and the underlying array, which in our case holds 6 elements. Now the slice pointer points to the first element of the underlying array. The length of the slice is 6, which is the number of the elements of the underlying array. The capacity is also 6, which is again the number of the elements of the underlying array. If we create a new slice from existing slice called second slice, Go will create a new slice header. The pointer will point to the element with index 1, which in our case is the second element in the underlying array. The length of the slice will be 3, so from the first index until the fourth index, and the capacity will be 5. So now we have 2 slices that point to the same underlying array. If we change an element on the second slice, let's say we want to change the element with index 1 on the second slice and assign the value of 6. The second element in our second slice, contains the value of 7. So we are changing the value to 6. But because both slices are pointing to the same underlying array, the value will be changed for the first original slice also, which in our case is mySlice. So let's start the IDE and let's test this. Let's delete everything from the main function and define the slice that we used as an example in the slides. So let's create the slice mySlice, which is a slice of integers, and let's add the values 12, 2, 7, 9, 4, and 5. Now let's create a function that will print the details for an int slice that we provide. So let's call this function print. Func print the slice that we are going to provide, which is slice of integer, and then this will do just format print. It will print in the screen basically the standard stuff that we used so far. So len is going to be number, cap is going to be a number, and then we want to print the details of the slice or the whole elements of the slice. So we do len s, then cap s, and then s itself. So now if we call the function print and provide the slice mySlice, we will see that it will print the details of the slice. So let's do that. Go run main.go, and you can see it has printed 12, 2, 7, 9, 4, 5, which are exactly the elements of the mySlice. We need to add a new line onto the print function. So now we want to create a new slice called second slice that will be created from mySlice. So let's do second slice, and it's going to be created from the slice mySlice, and it's going to start from index 1 up to index 4. Now if we print second slice, we will see, so if we go, we will see that the second slice has the length of 3 elements, capacity of 5, and it has the elements 2, 7, 9, which is exactly from the index of 1 on the underlying array. So because, as we said, because a second slice was created from mySlice, second slice and mySlice use the same underlying array. To prove that, let's go and change an element on second slice. So let's do second slice, and let's change the first element, second element with index 1. From value 7, let's change it to value 6. And let's print second slice now. Sorry. And if we run the application now, you can see that the second element has changed from 7 to 6. Let's see what happened to the slice mySlice. So let's print mySlice as well. And let's run the application. You can see that the element in mySlice has changed from 7 to 6, which proves that we are actually pointing to the same underlying array on both slices. We can do the same with mySlice. We can change an element in mySlice, and then we can see that it will change on the second slice as well. So let's do that. So let's change the fourth element, or the element with index 3, which in our case is number 9. We can see that the element with a value of 9 has changed its value to 15. Now let's try to append an element to the second slice, and let's see what happens. Let's delete some statements first. And now let's add an element with a value of 15 to the second slice and print the details. Append second slice, and we want to append an element with a value of 15. Let's print the slice and let's run the application. Right, now you can see that the length of the second slice has changed from 3 to 4, and the element with the value 15 has been appended to the slice. You may be wondering, since we are sharing the same underlying array, what has happened to the original slice, which in our case is my slice. Let's print the details of my slice also, and let's see what has happened. Print my slice. Let's run the application now. Okay, now we can see that an element on my slice has changed also. What has happened here? When we created the second slice from the original slice, which is in our case is my slice, we decided that the second slice will start from the second element in here, or with the element whose index is 1, and up to the element whose index is 4. So in total, we have 3 elements, which means that the slice has the length of 3. But because the capacity is 5, it means that we can add 2 more items on the second slice before reallocation. So when we are adding 1 element to the second slice, in reality, we are changing an existing element in the underlying array, which in our case, we are basically changing the value of element from 4 to 15. But what happens if we add more than 2 elements to second slice, therefore exceeding the capacity of the slice? Let's say we want to append another 3 elements on the second slice. The slice currently has the capacity of 5 and length of 3. By appending 3 more elements to the slice, we are exceeding the capacity of the slice. So what is going to happen? Well, we said before, when the capacity is exceeded by appending elements to a slice, Golang will create a new underlying array that has double the capacity, will change the pointer from original array to the newly created underlying array. It will copy the elements from the original underlying array and will append the new elements to the new underlying array. The length of the second slice is 6 and the capacity is 10. So now, as we can see from the slide, the slices are not sharing the same underlying array anymore, but they have their own underlying array each. And now when we change an element in one slice, it will not affect the other slice. So let's go back to the IDE and let's test all of this. Let's remove some statements that we don't need first. And now let's append 3 new elements to second slice. and let's add elements 10, 14, and 20, same as the ones we had in the slides. Let's print the second slice now, and let's run the application. So now you can see that after we appended the 3 elements, the length of the second slice changed from 3 to 6, and the capacity was doubled from 5 to 10, and then we have all the elements in the slice. Right, so now because the capacity of the slice has doubled on second slice, that means that the underlying array is not shared anymore, but second slice has got its own underlying array. And now if we change an element in second slice, it shouldn't affect the elements on my slice. Let's try that. Okay, so we don't need that. So let's do second slice, and let's change element with the index of 3, and let's change the value from 10 to, let's do 50, and let's print second slice, and let's print my slice also, and you will see that the elements in my slice hasn't changed. Right, so now this is our second slice. So the element has changed from 10 to 50, whereas the elements on my slice haven't changed at all. We can do the same with the change of one element on my slice. So let's change one element on my slice. So let's do, for example, element with the index of 4, and let's change 70, for example. Again, let's run the application, and now you can see that the element has changed from 4 to 70. The last thing to remember about slices is that, as we said before, when you create a new slice from existing one, the new slice will point to the same underlying array. So Go garbage collector will not be able to collect the underlying array until all the references to it are released. So let's imagine that we have a big text file and we need to go and get the first 50 characters from the file. So let's write the function. First, let's delete some data that we don't need so far. So okay, let's write a function called get characters. We provide the name of the file that we want to get the first 50 characters. So name is string, and then this returns a slice of bytes. So we're gonna read the bytes from file, was read file name, and then let's create a slice called characters that will return the first 50 bytes from slice data. Return cars. Okay, so now in the main function, if we call get characters function, so let's create a variable first, returned characters, and we calling get characters, and then let's do file dot. We have a file here, file.png. See this file here, just for demo purposes. And one thing that you may wonder is, why am I ignoring the error? I'm ignoring the error because I know for sure that this is the file that actually exists, but in general it's not a good idea to ignore the errors. We should really handle the errors correctly. Okay, so now let's print the details for this slice. So let's use print return characters. We need to change the signature of the function print, so it doesn't take int slices but takes byte slices. Okay, and now if we run application, you can see that the length is 50, but capacity is almost 190 kilobytes. So even though we only need 50 bytes from the underlying slice or from the file, we are actually keeping the whole underlying array in memory. Therefore, the whole file will be in memory until the main application exits. A much better approach would be to actually copy the first 50 bytes from the original slice in the func get characters and then return that rather than just creating a slice from the existing slice. So let's do that. So let's define a slice. So let's say characters. We want to use the built-in function make, and it's going to be a slice of bytes, and we want the length to be 50 and capacity 50. And then we use the command copy, and we are going to pass a destination. So this is going to be our characters slice, and the main slice is going to be data and return cars. So now if we run this application, you can see that we actually have only 50 characters. So what has happened here is that by us creating a new slice, we are actually creating a new slice with a new underlying array. And then we are copying the first 50 bytes from data to our cars slice, and that's much better and much more memory efficient. This concludes our video about slices in Golang. Thank you very much.